standard form of a linear equation. So the standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So you can't have both a and b equaling 0. We have what we call the slope-intercept form. This is what we've been dealing with, y equals mx plus b, where this is your slope and b is your y-intercept. But now we're going to talk about the standard form. And standard form is ax plus by equals c, where c is a constant, a and b have coefficients, or are coefficients of x and of y. An example of that would be something like 3x plus 4y equals 10. So as we're looking at the standard form, you are going to be able to graph these. And there's going to be a couple of steps that we're going to follow. The first thing we're going to do is we're going to find the x and the y intercepts of our particular problem. As you look at this problem, you do have, it is in standard form. Notice that you have 4x minus 9y is equal to negative 12. And to find the x and the y intercepts to graph this, you're actually going to plug in 0 for x. If you notice, here is our x-axis. And when you have the x-axis, any point along that, you have where y is 0. At this point, y is always 0. So if you had this point on the graph, for example here, that value would be negative 5, 0. That value here, if I had a point here, would be at 3, 0. No matter what thing you look at, the x-axis, anytime it crosses that x-axis, the y is 0. Now for the y-intercept, any point here, 1, 2, 3, 4, 5 up, it's going to be 0, 5. Or a point like right here, that would be negative, that would be 0, negative 4. You're going to notice in this case, x is always 0. So in order to find each intercept, so for the x-intercept, plug 0 in for y. And so you take that equation, 4x minus 9, and wherever you see that y, you're going to put the 0 in. And then you solve that problem. Anything times 0 is 0, so I get 4x equals negative 12. I'm going to divide by 4, and so I get x equals negative 3. So the x-intercept is a point. Again, we plug 0 in for y, so I'm going to put a 0 in for y, and my x value is negative 3. Now, consequently, for the y-intercept, I'm going to put 0 in for x. So plug 0 in x. So we write the same equation, only now you're going to plug 0 in where there's an x value. And then you're going to solve that. So you get negative 9y equals negative 12. Divide by negative 9. A negative divided by a negative is a positive. And then I can reduce 12/9 into 4/3. So again, when I rewrite that, we put a 0 in for x, so you're going to put 0 for x, and the y value is going to be 4/3. So this is the y-intercept. So the two steps that you need to understand in order to find the x and y intercepts, to find the x-intercept, plug 0 in for y and solve. For the y-intercept, plug 0 in for x and solve. So now we're going to graph it using those intercepts. In order to graph a linear equation, you just need 2 points. And we're going to use the standard form of graphing, which means that we're going to find the x and y intercepts for our equation. So the first one, we are going to plug 0 in for y and solve it. So we get 5x equals negative 10. Divide by 5, x equals negative 2. Write it as a point so that you know what you're going to graph. We plugged 0 in for y, so I'm going to put a 0 in my point for y, and x is negative 2. That is our x-intercept. So on my graph, I'm going to go left 2 units and up 0, or down 0. So that's my x-intercept. Now I'm going to find my y-intercept. And I'm going to do that by plugging 0 in for x. 5 times 0 is 0. So I get 2y equals negative 10. Divide both sides by 2. Y equals negative 5. Again, writing it as a point, I put a 0 in for x, and my y is negative 5. So my y-intercept, go down 5 units on the y-axis and put a point. Now that I have 2 points on my graph, I'm just going to connect them with a straight line. Put arrows on my graph, and there is the graph of 5x plus 2y equaling negative 10. Notice that you could change that graph or that equation into a linear form if you wanted to, because you could find the slope of that equation and the y-intercept, so you could put it in a slope-intercept form. We're going to do that eventually, but first we're just going to work on graphing these types of equations. Now there are some special types of equations. When we look at these, we have y equals 5, y equals 0. Then we have x equals negative 4 and x equals 0. When we have y equals, that means that the y is always 5, no matter what. So no matter what my x value is, if my x value is 5, my y is 5. If my x value is 2, my y is 5. If my x value is negative 3, my y is 5. No matter what, y equals 5. So if I were to plot those points, let's say 5, 5, 2, 5, negative 3, 5, you're going to notice that each of these points, y equals 5, are all on this horizontal line. So at y equals 5, it's going to be a horizontal line at 5. Now if y equals 0, that is also going to be a horizontal line, and those are going to actually be right on the x-axis. So this one, y equals 0. Okay. This one was y equals 5. Notice that if it's y equals, it's a horizontal graph. Okay, and so it's y equals some number. So thinking about that, you can see that the slope of those is going to be 0. Again, it's 0 fun. If you had to walk across something that had no slope, you wouldn't be able to do much in terms of skiing down that slope of 0 because you wouldn't go anywhere. So that has a slope of 0. Now looking at x equals negative 4 and x equals 0, let's see what those look like. If x is always negative 4, regardless of what your y value is, let's see what those kinds of problems look like. Graphing that, negative 4 is 0, it's there. Negative 4, positive 2 is there. Negative 4, negative 3 is there. You're going to notice that this starts creating a vertical line. So connect those dots. So anytime you have something where it's x equals, you're going to end up with a vertical line. So a vertical line is always in the form of x equals something. In this case, x equals 0. That means that it would be here, here, all of these is where x is equal to 0. And so in that case, it would be a vertical line on the y-axis. So again, these are the two special types of equations. They don't necessarily look like they're in slope-intercept form or in standard form of any kind. But you're going to notice if you have y equals just a number, that is a horizontal line. If you have x equals just a number, that is a vertical line.